Welcome to our deep dive into the integration of fire alarm and safety systems within building management systems, or BMS. In today's world, ensuring the safety of building occupants and assets is more critical than ever. By connecting fire alarm systems with BMS, we unlock faster emergency responses, smarter equipment coordination, and centralized control. Throughout this video, we'll explore how these systems work together, the benefits of integration, and the essential protocols that keep everyone safe. Let's begin by understanding why this integration is a game changer for modern buildings. The primary goal of integrating fire alarm systems with BMS is to ensure life safety and protect valuable assets. This integration provides real-time alarm visibility right on the BMS graphical interface, enabling building operators to respond instantly. It also allows for automatic shutdown or startup of critical systems like HVAC, lifts, and dampers during emergencies. By coordinating emergency lighting, access control, and even CCTV responses, the BMS helps streamline evacuation and emergency protocols. Additionally, integration supports comprehensive reporting and compliance with local fire safety codes, making it easier to meet regulatory requirements. Let's take a closer look at the main components of a fire alarm system. At the heart is the Fire Alarm Control Panel, or FACP, which acts as the central logic and monitoring hub. Smoke and heat detectors provide early warning, while manual call points allow anyone to trigger an alarm. Audible and visual devices like sounders and strobes alert occupants. Relay modules enable the system to interface with external equipment, such as HVAC units. Loop interface cards manage addressable detection loops, and a battery backup system ensures the fire alarm remains operational during power outages. Each component plays a vital role in a comprehensive safety strategy. There are several ways to connect fire alarm systems with BMS. The most common method uses dry contact simple relay outputs from the fire panel wired directly to BMS digital inputs. For more detailed data exchange, protocols like Modbus or BACnet are used, allowing serial or IP-based communication. Advanced systems may use OPC, API, or SNMP for software-level integration, especially with smart panels. Typically, dry contacts are used for immediate actions like shutting down HVAC, while Modbus provides detailed status updates. Choosing the right method depends on the building's needs and the complexity of the systems involved. When a fire event occurs, the BMS springs into action. For example, if a fire alarm is triggered in an air handling unit (AHU) room, the BMS will stop the AHU close dampers and display an alarm pop-up. If smoke is detected in a specific zone, the system isolates variable air volume (VAV). Units and shuts return air dampers to prevent smoke spread. Manual call point activation on a floor can unlock access doors and display relevant CCTV feeds. In the event of a main fire alarm, the BMS can stop chillers, disable elevators, and send alerts to operators and security teams. These coordinated responses are crucial for effective emergency management. One of the most critical actions during a fire is the automatic shutdown of HVAC systems and control of dampers. HVAC units, if left running, can spread smoke and fire between building zones. The BMS automatically stops supply and return fans, closes motorized fire and smoke dampers, and shuts down fan coil units and valves in affected areas. If an external fire is detected, outside air intakes are also cut off. These actions help contain smoke and fire, buying valuable time for evacuation and firefighting efforts. Proper damper control is a cornerstone of building fire safety. During a fire emergency, the BMS coordinates multiple systems to aid safe evacuation. Access control systems automatically unlock exit doors and escape routes, ensuring no one is trapped. Emergency lighting switches on to illuminate escape paths, even in smoky or dark conditions. Elevators are returned to the ground floor and disabled to prevent use during a fire. The public address PA system can broadcast emergency voice announcements, guiding occupants to safety. This seamless integration of access, lighting, and communication systems is essential for a swift and orderly evacuation. Modern BMS interfaces provide interactive floor plans that display real-time fire alarm status. Activated detectors are shown as flashing icons, and the exact location of fire alarms or manual call points is highlighted. Zone-specific alarms, such as smoke or heat detection, are clearly marked. The system can also integrate with CCTV feeds, giving operators visual confirmation of the situation. For critical alarms, the BMS GUI auto-populates alerts with sound, ensuring immediate attention. This level of visualization greatly enhances situational awareness and speeds up emergency response. Accurate alarming and logging are vital for both real-time response and post-incident analysis. The BMS logs various alarm types, such as fire alarm activation, smoke detection, damper feedback failures, and unsuccessful AHU shutdowns. Manual call point activations are also recorded. Each event is time-stamped and can be reviewed later for compliance and improvement. These logs not only help operators respond quickly, but also provide valuable data for audits and regulatory reporting. Effective alarming and logging ensure that no critical event goes unnoticed. Compliance with fire safety codes and standards is non-negotiable. Key standards include the NFPA from the USA, EN54 in Europe, and the UAE Fire Life Safety Code for the Gulf region. Integrated systems must support fail-safe logic, battery-backed operation, and periodic testing with acknowledgement. These requirements ensure that fire safety systems remain operational under all conditions and that integration with BMS does not compromise their reliability. Adhering to these standards is essential for legal compliance and, more importantly, for saving lives. A robust fire BMS integration must include redundancy and failover measures. The BMS should never control the core logic of the fire system, it should only react to signals from the fire panel. Manual override options must always be available, and the fire integration should function even if the BMS is offline. Using fire-rated cables and isolated circuits further enhances system reliability. These precautions ensure that, in the event of a system failure, life safety is never compromised and emergency protocols remain intact. Let's walk through a typical fire BMS sequence, such as an AHU shutdown triggered by smoke detection. First, the fire panel sends a digital signal to the BMS controller. The BMS then stops the AHU supply and return fans, closes the return air and fresh air dampers, and activates an alarm on the BMS GUI with a red highlight on the affected floor zone. Finally, notifications are sent to the operator and security team. This sequence demonstrates how integration enables rapid, automated, and coordinated responses that protect both people and property. In summary, integrating fire alarm systems with BMS brings significant benefits: enhanced life safety, improved situational awareness, and faster emergency response. While the fire system remains autonomous and code compliant, the BMS acts as a smart responder, controlling HVAC, access, lighting, and visual alerts. Remember, the key to effective integration is maintaining system independence, ensuring redundancy, and always prioritizing safety. By leveraging technology and best practices, we can create safer, smarter buildings for everyone.